Hello, everyone. This is Fabian, Group Manager for Product and Enablement for the database kickoff video for 14.4, GitLab's next release. This is a very exciting recording because I'm also joined with Yannis, who you know, who creates better kickoff videos than me. And he's officially joining us as the Senior Product Manager for database and memory. So going forward, he's going to create these videos again. And today we'll walk through where we are with the database team, what we're focusing on, and also discuss a few sort of more directional items of what could come next. And really looking forward to hearing your opinion on those, Yannis, as well. Awesome. Okay, I'll share my screen. So the first thing to note is that GitLab is focusing right now on the availability and stability of GitLab.com. And so we are addressing so-called infra-dev issues, which are actually being sort of, they are created as part of us trying to understand what keeps GitLab.com stable, what are the improvements that we need to make. And so right now, as we speak, there are none that the database group has to address, but they can pop up, for example, as the result of incidents, and they're a top priority for the team. So this is something that we are continuously pursuing. The second thing is the sharding blocker issues. In another video that I'll record, I'll talk a little bit more about our ongoing effort of decomposition. This is our effort to allow for increased scalability and headroom in GitLab.com. What we're doing there is we are essentially taking all of the CI tables and we're moving them to a different database. And so as part of that, many of the tools that the database group has built to support migrations, for example, or to handle how we treat the database are broken, because now we have to deal with more than one database. And this is something that the database group is actively working on to support the sharding team. So there are a few examples, for example, fixing the broken database helpers, fixing the migration helpers to support many databases, ensuring that our partitioning code works with more than one database. These are really important things that we need to put in place before we can actually migrate to a world where the CI tables are living on a separate database, and we can support that on GitLab.com. The next thing I'd like to talk about, and this has been highlighted on a number of occasions because it's really important, is our work to address the primary key overflow risks for tables where the primary key is an integer. So GitLab.com, and this is important to highlight, this is mainly relevant to GitLab.com because we have so much activity on this instance. And so there are a few tables that are essentially running out of growth because there are only so many integers available. And the database team has worked to ensure that we can replace those integers, these primary keys, with big integers, which have a lot more potential. And so correct me if I'm wrong, Yannis, I think we've now mitigated this for 10 out of 13 tables, which is very exciting. I'll show you a little plot here as well that highlights the work that the team is doing in that area. It takes a little while to refresh. Here we go. So for example, only a couple of days ago, the CI builds table, which had 75% roughly of integers used, was swapped and now actually uses a lot, like essentially is on big integers. That is a really important and critical step in mitigating this risk. There are a few follow-up steps that the database team has to do, and this is exactly what's going to happen in 14.4, which is, for example, to drop the triggers where the old integer-based table is still being updated, and then also removing the tables that are no longer needed, or the old integers. And this is all, like, you could argue it's like, oh, this is something that can be easily done with some downtime. But as this is relevant for GitLab.com, we had to implement a process that actually allows us to do this with minimal interruption to GitLab.com and no downtime. And that means that this process takes a longer time. There are specific steps that need to be executed in order. Those steps are understood a lot better by Yannis than me, but there are still a few things to do. Essentially swap columns for 3 more tables, and then finalize all of the other steps. But we're very confident that we can get that done in 14.4. And then, and this is interesting, and here, Yannis, I'm really excited to have a quick chat for the benefit of our viewership. This work regarding the primary key overflow risks is coming to a close. And that means that the database team is now in a position where we can start to pursue new initiatives. And this is going to be, I think, something that you will spend a lot of time on, is understanding what we are going to do and why we are going to do it in that specific order. And so Craig, the engineering manager for the team, has kindly put in a number of epics here that we can review. And maybe, Yannis, you can give me your sort of first impression of what these are about and why we need to care about them.
Yes, of course. So we have, those are 4 different directions, 4 different things that we want to do at some point. So first of all, whatever we do, we want tables, we want to reduce the size of all tables below 100 gigabytes. So having tables that are at 1 terabyte, that are huge tables, makes everything slower, and makes also our lives on migrating and solving issues and making updates much more difficult and more risky also. So this is the first one. This epic is about trying to reduce all tables below 100 gigabytes. That can be either by partitioning them or by doing other tricks like removing some columns, for example, taking JSON information out of the database, splitting tables, or whatever. So this is very important for us because having all tables below 100 gigabytes will allow us to be way more agile, more fast on addressing issues and making updates.
I think that's a really great point, and I love that we this is something we can measure. We know the size of the tables in our database, and I think this is going to have many benefits because it will also allow us to review some of these data. And I think a good example where in the past, I think we've been able to reduce the size of tables and also the size of the data overall was webhook logs, where I think we also have a retention policy now. So we are able to drop data after a certain amount of time because we know that we don't need it anymore. I think these are some of the strategies that we can employ to control the growth of the database and also control the size overall of the tables, as you said. I think that's really valuable to GitLab.com specifically, but also for our self-managed customers, because we can ensure that when our customers grow, the database grows in a way that actually is controllable, and we don't get into a state where you have like a terabyte big CI table, even though that is probably something that is very far off for many self-managed customers, but who knows?
Yeah, and all our solutions will benefit all instances, even smaller ones. It won't be that crazy of a change, because if we implement partition and we partition the table, all tables for all instances will be partitioned. So you will have smaller tables. Even if a table was 1 gigabyte instead of 500 gigabytes, will now be in smaller chunks of 100 megabytes. So even that one will be smaller, and of course it will allow all instances to grow. And the same is true for moving columns outside of the database, or data outside of the database, or reducing the database, the data set size. So I think that it's important for GitLab.com and for all instances as well.
Sounds great, thank you. And then maybe we can spend a little bit of time talking quickly about the automated database testing, because I think that's also something that may be quite relevant in the longer term for what we would like to offer at GitLab, even though that is something we still have to discuss.
Yeah, we have to think about it. For sure, we are at step 3 of the maturity of this feature. We are using it inside. It has been very useful for us. So the idea there is that whenever you at the moment this is tested and used by the GitLab engineering team, whenever someone makes an update that is database related, we now can test it against a real production clone, which is amazing for us. That means that whenever we make any change, we are able to test it against our production database at the size of GitLab.com's database and not a test database, which means that we can see problems early, find problems, find either performance issues or real issues like, there are some types of data sometimes that may break a feature. And that has been proven very, very useful for the GitLab team. And we want to continue building that going forward, because at the moment we are testing migrations, which are database updates. We will want to extend it and being able to test more things. And maybe at some point, and this is open for discussion, this is something we are discussing and brainstorming about it internally, we could even start thinking how we could roll it out and make available such a feature to other instances and other development engineering teams.
Sounds great. Thank you. I can quickly talk about improving the migrations for primary key conversions, because we talked about this earlier and the process that goes into it, and there are quite a few steps. And so one of the things that we may want to consider is streamlining this process. So if in the future this becomes an issue again for some tables, which we also hope to avoid in the first place, then it is more efficient to have tooling for other teams available to do this and to be confident in being able to do it, rather than the database team having to do it for them. And so that's a pattern that I think we try to establish in many areas of GitLab. It's like, if you teach others how to help themselves, you are free to improve the tooling or focus on other things, rather than being operationally clogged up by having to do all of that. And that's the natural sort of next step after this big effort the team has gone through.
Yeah,
so we'll look at that.
And this is also the process of the team sitting down and writing whatever we learned about this. So it's writing the tools and also having a summary for everyone of what happens here, how we can do it, what are the tools, how you can self-serve, but also how you can do it again if we have a similar problem in the future. But the most important, sorry.
No, sorry, I interrupted you.
Yeah, but the most important part is the last bullet, in my opinion, which is the result of all this effort and battle testing all this new approach in order to solve this very hard problem while we had zero downtime. We had to build a new framework for running background migrations. And what are background migrations? We never do anything live. In a huge production system like GitLab.com, and also that's true for all our large instances, GitLab instances out there. You want to only do updates that take no more than a minute or a few minutes, because you don't want to block or affect production. So what we are doing when we have huge updates, we are doing background updates where we have a lot of background processes making the update in parallel with GitLab running. So in order to solve this problem, we had to build a new background migration framework that we battle tested it with the primary key conversions. And the idea here, because it's advantageous to everything we have at the moment, is to have a general availability and make this the framework for everything, for all background migrations in GitLab. That will mean that all migrations in GitLab at some point after we release this, will be able to run in the background, unattended, and with all the giving the confidence to us and all instances that they will finish at some point, which is very important.
Yeah, and I think this is really important given our rapid upgrades also for self-managed customers, because this happens, and we want to make sure that this is really robust and there are no issues in the process. And I think that having a framework where developers can rely on it and we can ensure that there are no issues with it is, I think, very valuable.
Yeah.
Super. I think that's a great overview. I'll stop sharing my screen. I'm really excited about finishing the primary key conversion work in 14.4. I'm even more excited about what you're going to do with the team and the direction that you're going to take. So thank you very much for listening. I hope you have a lovely rest of your day wherever you are, and we'll talk soon about database latest in the next release. Bye-bye.